Join me as I dive into the mind-blowing scenario of two neutron stars colliding in our galaxy and see if I can explain what would really happen. Two tiny corpses of stars, each no larger than a city, but heavier than our sun. Imagine them spiraling toward each other in a dance of doom. Now, imagine this happening not in some faraway galaxy, but right here inside the Milky Way. What would it look like? What would it mean for us? And would Earth survive? Neutron stars are the remnants of massive stars that exploded as supernovas. They pack the mass of the sun into a sphere only about 20 kilometers wide. A teaspoon of neutron star material would weigh 1 billion tons. The Milky Way holds billions of stars, and sprinkled among them are dozens, maybe hundreds, of neutron star pairs destined to collide. Neutron stars are among the most extreme objects in the universe. They're what's left after a massive star undergoes a supernova explosion, leaving behind a dense core that's incredibly heavy. Imagine taking the mass of a mountain and squeezing it into a sugar cube. That is basically what a neutron star is. These tiny giants are scattered throughout the galaxy, and their collisions can have far-reaching consequences. When two neutron stars orbit each other, they slowly lose energy by sending out gravitational waves, ripples in space-time. As they spiral closer, their orbit tightens, their speed increases, and in the final seconds, they move at a significant fraction of light speed before colliding in a titanic explosion. The potential consequences of neutron star collisions are nothing short of cataclysmic. When two of these dense objects collide, they release an enormous amount of energy in the form of gravitational waves, gamma-ray bursts, and even heavy elements like gold and platinum. This explosion is so powerful that it can be seen from millions of light years away, and its impact can be felt throughout the galaxy. The energy released can distort space-time itself, sending ripples that propagate through the cosmos. Surrounding space gets a serious shakeup, with the potential to affect the orbits of nearby stars and planets. If a neutron star collision happened inside the Milky Way, the explosion would be brighter than any star in the sky. For days, maybe weeks, it could rival the full moon in brightness. You could walk outside at midnight and cast a shadow from a light source 100,000 light years away. Humanity would watch in awe. The immense energy released also has a profound impact on the surrounding interstellar medium, which can lead to the creation of new stars and planets. This process can even influence the formation of life in the galaxy. The collision can also produce a massive amount of debris, including neutron-rich material that can be flung into space, potentially seeding the formation of new stars and planets. But the beauty hides something extraordinary. Neutron star collisions forge heavy elements: gold, platinum, uranium. Every gold ring, every necklace, every coin on Earth was born in an ancient collision like this. A single event could produce more gold than Earth has ever held. The collision of neutron stars is a complex process that involves some of the most extreme physics in the universe. When two neutron stars collide, their merger creates a massive amount of gravitational wave energy, which was predicted by Einstein's theory of general relativity. This energy is released in the form of gravitational waves that propagate through space, carrying information about the merger. The collision also produces a gamma-ray burst, an incredibly powerful explosion that releases an enormous amount of energy in the form of X-rays and gamma rays. But here's the danger. Kilonovas produce intense radiation, especially gamma-ray bursts. If the Earth were unlucky enough to be in the path of one of these deadly beams, the results would be catastrophic. Our ozone layer stripped away, ecosystems collapsing, and possibly a mass extinction. The odds are small, but inside our own galaxy, the risk is real. The mechanics of neutron star collisions are also closely tied to the formation of heavy elements. When neutron stars collide, they create a massive amount of neutron-rich material that gets flung into space. This material can then be incorporated into new stars, planets, and even life forms, potentially explaining the origin of heavy elements like gold and uranium. In 2017, scientists detected gravitational waves from a neutron star collision 130 million light years away. Imagine the signal if it came from within the Milky Way. Detectors like LIGO and Virgo would nearly burst with data. It would be the most studied event in scientific history. the universe itself shouting through the fabric of space. In a galaxy like ours, the collision of two neutron stars is a rare event, but it's not impossible. If it were to happen in our galaxy, the effects would be dramatic. The explosion would be visible from Earth, and the impact on our planet would depend on the distance between us and the collision site. A nearby collision could potentially cause massive destruction, while a more distant one might have little effect. A nearby neutron star collision would do more than awe or threaten us. It could unite humanity. Imagine billions of people watching the same cosmic fireworks. Imagine religions, governments, and cultures interpreting the event differently. Some as an omen, others as proof of cosmic creation. For once, the whole planet would look up together. The real-world implications of neutron star collisions are still being studied, but they could have significant effects on our understanding of the universe. These events can provide insights into the fundamental laws of physics, such as gravity and relativity. They can also help us better understand the formation of heavy elements and the origins of life in the universe. After the flash fades, the remnants remain. Perhaps a black hole or a massive magnetar. A neutron star with a magnetic field so strong it could erase credit cards from millions of kilometers away. These remnants could reshape nearby star systems and continue influencing their cosmic neighborhood for millions of years. The most dramatic scenario would be if two neutron stars collided close to our solar system. The effects on Earth could range from spectacular light shows in the sky to devastating effects on our atmosphere. While the likelihood of such an event happening anytime soon is low, it's essential to understand the potential risks and consequences. The truth is, survival depends on distance. If the event happened thousands of light years away, we'd enjoy the show safely. If it were closer than a few hundred light years, radiation could devastate Earth's biosphere. It's a game of cosmic roulette, and we don't control the wheel. So, what if two neutron stars collided inside the Milky Way? It would be the greatest spectacle humanity has ever witnessed. A cosmic symphony of creation and destruction. Golden light, radiation, and ripples in space-time, all from two dead stars colliding, beautiful, terrifying, and a reminder that the universe is alive with power beyond our imagination. In summary, the collision of two neutron stars in our galaxy would be an event unlike any other. The sheer energy released, the creation of heavy elements, and the impact on surrounding space would make for a spectacular sight. So, what do you think about neutron star collisions? Have any thoughts on what would happen if two of these extreme objects collided in our galaxy? Let me know in the comments below. If you're fascinated by cosmic phenomena, be sure to check out my next video on black hole mergers and their role in shaping the universe.